Hello, in this video we're going to be talking about the fairness criterion and also Arrow's impossibility theorem. We're also going to review each of the four voting methods quickly. So here is a table that has all of the MAS examples that we did for each of the voting methods. One thing that is interesting about the results is that the winner was different for each of the voting methods that we looked at. So again, one of the interesting things that came out with this example is that each method resulted in a different winner. And the rankings for each method are also in this table, so you can see what those were as well. Next, we've looked at each of these criterion in other videos, but just wanted to get it all in one place. So first we had the majority criterion, and that's if a candidate has the majority of the first place votes, that candidate should win the election. There was the Condorcet criterion. If a candidate wins all of their pairwise comparisons, in other words, they're the Condorcet candidate, that candidate should win the election. Next we have the Monotonicity criterion. And this is if a candidate who would otherwise win an election, they should not lose the election because some voters change their ballots in a manner that favors that candidate. So let's say candidate B wins the original election. If some voters move candidate B up on their ballot, so they prefer them more now, that should not cause candidate B to then lose the election. That's what the monotonicity criterion is. Next, we have the independence of irrelevant alternatives criterion, and again, this one you can just call IIA. A candidate who would otherwise win an election should not lose because one of the losing candidates withdraws from the race. Arrow's impossibility theorem, this just proves that it is mathematically impossible for a voting method to satisfy all of the fairness criteria. Now we're going to take a look at three examples that are going to bring out each of these criterions. So here we have a preference schedule, and we want to determine the winner using the plurality method. So with the plurality method, remember it's the number of first place votes that a candidate has. D has 9 first place votes, and A has 5, and C has 8. And so candidate D wins using the plurality method. Next, we want to determine the winner using the pairwise comparison method. So we need to pair everybody up. So now we have each of our pairwise comparisons set up. First we're going to look at A versus B. So B will win the first 6. A wins the next 3. A wins actually the next 13. So A has 16 and B has 6. So A is going to win that matching. A versus C. So A wins the first 9, 14, and then C wins the last 8. So A wins that one. And then A and D, D will win the first 9, and then A wins the next 13. So A will get that point. And then B and C. So B wins the first 9, and C wins the 13. So C is going to get that point. Next, B and D together. So D will get the first 9, and B gets the next 5, and D gets the next 8. So D has 17 and B 5, so D is going to get that point. And then C versus D. So D gets the first 9, and C will get 13. And so C is going to win that point. So A has 3, B doesn't win any, C wins 2, and D wins 1. And so A is the winner. Not only is A the winner, but A wins all of its comparisons. So these are the only pairwise comparisons that A is involved in, and they win all of them. And so A is known as the Condorcet candidate. And since A does not win using the plurality method, this is breaking the Condorcet criterion. And so then explain why this is true. So the reason why this is true is because A is the Condorcet candidate, but does not win using the plurality method. Right, so the Condorcet criterion says that if a candidate is the Condorcet candidate, then they should win the election no matter what. Candidate A is the Condorcet candidate, but they do not win when we use the plurality method to count the votes. Now we want to recreate this preference schedule if candidate A drops out of the election and determine the winner using the plurality method. So let's recreate this. So we're only going to have 3 candidates in our election. And it was 6358. And so if we take A off the first 6 ballots, they would be DBC. If we take A off of the next 3, they would become DBC. If we take A off of the next 5, those ballots would become CBD. And then the last 8, if we take candidate A off of those, they would become CDB. And now we want to figure out who will win using the plurality method. So D has 9, and candidate C has 13. So candidate C would win. And so A dropped out of the race, but A was not the winner originally using the plurality method. D was. But A dropping out, somebody who originally lost, causes D to no longer be winning. And so that is the IIA. Okay, so, and that is because A drops out, causing D to now lose the election. In this next example, we have 3 candidates, and we want to determine the winner using the plurality with elimination method. So we have candidates A, B, and C, and count how many first place votes they have. Candidate A has 6, candidate B has 5, and candidate C has 6. We need for one of the candidates to have the majority of the first place votes, so we need to determine how many voters there are in this election, and so we have a total of 17 voters in the election. Divide 17 by 2, and that will give you 8.5. And so we need a total of 9 in order to have majority. So nobody has the majority right now, so the candidate with the least number of votes is going to be eliminated, and that's going to be candidate B. And so if we look on our preference schedule, A is the next candidate down on those ballots. So those 5 votes will get passed to candidate A, giving candidate A a total now of 11. And so A wins. If the voters of the last column change their preference to ACB, who wins the election? So instead of this last column being CAB, we're going to switch those to ACB. So what happened is they changed their preference, their first place preference from candidate A, or from candidate C to candidate A. So they just flipped candidates A and C around on their ballots. And so now let's see who wins. So A now has 8 first place votes, candidate B has 5, and candidate C has 4. So we're going to eliminate candidate C, and we're going to pass those votes to candidate B. And so now candidate B wins. So what happened is these last 2 voters said, well, I prefer candidate A more, and that actually causes candidate A to no longer win the election. And so this is the monotonicity criterion. So 2 voters moved A up on their ballots. Causing A to lose. And in our last example, we have a new preference schedule. And so we want to determine the winner using the plurality method. And so A has 51 first place votes and C has 49. So A wins. And what's special about this winner is that they have the majority of the first place votes. And now we want to determine the winner using the board account. So remember, with the board account, they get a certain number of points depending on what place. So first place will get 3, second place 2, and last place 1. And so when I do this, I like to write out A and then 3 times plus 2 times plus 1 times. Do the same thing for B. 3 times plus 2 times plus 1 times. And then candidate C, do the same thing. And then fill them in and do the calculations. So A had 51 first place votes, so 51 times 3. And they didn't have any second place votes, and they had 49 last place votes. So 3 times 51 plus 49, and that gives you 202. And candidate B doesn't have any first place votes. They have 49 second place votes, and they have 51 last place votes. So 2 times 49 plus 51 gives us 149. And then candidate C has 49 first place votes and 51 second place votes and 0 last place votes. So 3 times 49 plus 2 times 51, and that gives us a total of 249. And so C wins. So which criterion is being broken here? And it's the majority. And explaining that, so candidate A has the majority of first place votes. But does not win using the board account method. That is it for this lecture. Let me know if you have any questions, and I hope you're having a great day. Thanks.